My name is Hooman. I'm the VP of Technology at Fastly. I'm going to insult your intelligence for a second, if that's okay. I'm going to ask you some questions, and this is because I've made this mistake a few times. If these are stupid questions, just humor me. How many of you know what a CDN is? Great. How many of you are using a CDN? Great. How many of you would say you know what caching is, caching headers, and things like this? I love you guys. How many of you seen the Royal Tenenbaums? Good movie, right? Okay, I'm going to talk about dynamic content today, and it's probably a good idea to start with saying that it's cool, and then defining it. So what is dynamic content? Traditionally, dynamic content is this generic bad term that we've started using, or we have used for a while, for everything that isn't static. So in the world of the web, where you say my CSS is static and I have static images and I have static JavaScript, you generally talk about your base HTML or maybe some other things as being dynamic, things that aren't really cacheable, or maybe a better way to put it would be predictably cacheable. In the world of the web, this is basically I'm a web guy, so I'm going to talk about more webby stuff. This is basically the base HTML, that first request that we get in a page, and it's a big deal for us because that first request is a blocking request. The browser can't do anything until that HTML shows up, and it can parse it and start showing you pictures and pretty things. Sometimes it's also a larger object, so it'll take a bit more time to download it. So it's kind of it's a dynamic object, but it's also a sensitive object because it's that first thing. How many of you are familiar with this, a waterfall chart? Great. I don't have to explain it. You have probably seen lots of waterfall charts. You've probably never ever seen one like this because it's extremely clean and very predictable and very nicely formatted. That's because I made it up. But if you've looked at waterfall charts before, you've probably seen this part. And that part is the base HTML. And because it's dynamic and the server needs to do some work to generate it, it sometimes takes longer to download it or to get the first byte for it. That could also be because of the fact that it may have to go longer distances to get to an origin. Like if you're using a CDN and you're very far away from the origin, it's got to go far away. So time to first byte on the network is also long. But also the server may be doing stuff. Because it's blocking, it's kind of a big deal. Notice how nothing else happens on that page until the HTML gets there. That's why we're sort of very interested in base HTML as a dynamic object. Sometimes it's also bigger, so it takes more download time. This little blue thing right there, that's essentially what download time is. If you've ever used waterfall tools like this, you'll know that that's a thing, and it takes longer to download. So that's kind of what dynamic content is, but it doesn't stop there. It's not just the world of the web, even though we'll talk a lot about base HTML and HTML caching and things like this. It could be other things. It could be AJAX calls. It could be API calls. It's basically this catch-all term we use for things that we're uncomfortable calling static. It's a misnomer, and we'll get to that actually later. Maybe there are better terms for it, but that's kind of the kind of content that we're going to be talking about today. Traditionally, when it comes to CDNs, we've kind of taken a no caching approach to dynamic content. So if a content is dynamic, or if we're nervous that it may change or it's not as static as we think it is, we say, okay, hands off, no caching on this particular object because all sorts of shit could go wrong. Why is that? Why have we taken a no caching approach? Well, I would say that it's probably because of two main reasons. There may be other reasons, but I'm going to highlight two of them. The first is we are terrified of serving stale content. We hate it. We have no idea what to do with it when it happens, and we don't like doing it. It's not a thing. We are in a real-time web, real-time blah, blah, blah. We really dislike serving stale content. And primarily that's because we have not been given a very good invalidation framework. Let's talk about that for a second and try to dissect caching versus invalidation. Now, the best way to discuss this is to go to the source. And the source for me is, this is a little bit awkward because it got ripped apart about 45 minutes ago, is HTTP 1.1 and RFC 2616, which to me is the Sistine Chapel of technical documents. It's magnificent, it's awesome. And if you were to go look at it and read it, which I'm sure you all do nightly, like me, and you do a search for the word cache, you'll see 616 references to that word. Those are primarily in section 13, which is what defines the caching ways of HTTP 1.1, gives us lots of knobs, levers, gives us lots of control over how to cache things. Now, I'll admit it's pretty dorky to kind of know this off the top of my head, that it's 2616 and the 616 references, but I will say that it's dorkier to notice that there are 616 references in RFC 2616. Yeah, right? And I'm also honored to tell you that I didn't catch that, so that's yay me. So that's how many references you see to caching. The RFC gave us lots of control over how we cache things. But if you were to guess, just yell it out, how many references there are to invalidation in RFC 2616, what would you think? Yell out something. You're absolutely right, 7. There are 7 references to invalidation, actually 7 references to invalidate. 5 of those are in this section that say if you do a post, a put, or a delete, you should put, post, or delete the content that you're referencing. There's 1 reference in the table of contents for this section. And for you really drafty nerds like me, I'm one of you, there is 1 reference to the word invalidation towards the end of the RFC in the obligatory half paragraph that says, hey, security. So that's the 7 references that there is to invalidation. Point being that the RFC, as magnificent as it is, didn't give us a way to invalidate. It just gave us rules for how to cache it, but not to how to invalidate it. That is interesting, right? And it's not that we didn't think it was important. We actually did think it was important. You've never seen this before. This is the Web Caching Invalidation Protocol, Web Cache Invalidation Protocol. It's from 13 years ago, and there are 2 drafts of it. The reason it never happened was it's complicated. We were all so excited about 1.1 at the time. We're like, hey, we'll just cache, everything is cool. Never went anywhere. So we've had basically no way to invalidate content, certainly no good rules that the spec community provided for us. So we were basically there with these awesome ways to cache stuff, but no way whatsoever to invalidate it. That's the first problem. So the lack of a good validation protocol is the first problem that we've typically has caused us not to cache dynamic content. The second problem is one of visibility. What do I mean by this? We really like log files. We really like looking at Apache log files. We really like looking at stats. And typically, we really like this a lot more on our pages than on our images, for example. So like we really prefer to look at our Apache logs for page.html or page.php versus image.png. That loss of visibility, were we to push this page to the ether being the CDN, is another thing that's kind of made us nervous about caching dynamic content. And that has basically led us to no caching. Okay, so if we haven't been caching it, what have CDNs been doing all this time with dynamic content? What CDNs have been doing is essentially this notion of optimizing transport. You may have heard a term like DSA, dynamic site acceleration. I think of it as optimized from origin delivery, get things from the origin to a user that's far away as effectively as possible. This includes middle mile optimizations, it includes lots of TCP tweaks, and it kind of looks like this. Or this is one version of it. You have a user on the West Coast that's going to a CDN node on the West Coast, your origin's on the East Coast. That connection between the CDN node and the origin is super optimized. If I'm the CDN, you're my customer, I say, hey customer, why don't you configure your origin with these TCP things, and I'm really good at these other TCP things, I'll take care of the browser, don't worry about it, why don't we do some cool shit between the node and the origin. That's one way. This is kind of an asymmetric way. There's also the symmetric way, which is for me as a CDN to sort of take that traffic through this longest path between 2 of my nodes. So the traffic goes from the client to a CDN node in LA or on the West Coast all the way to a CDN node on the East Coast and then to the origin on the East Coast. Because I being the CDN, own those 2 CDN nodes, there's lots of cool TCP stuff that I can do between those 2 nodes. That is optimized. The reason that line got fatter is because there's lots more stuff you can do once you own both sides of the connection. So this is another way that we've been sort of handling delivery of dynamic content in the world of the CDNs traditionally. And it's not that we didn't try. We did, we have, we still do try to cache dynamic content. One way we do it is by setting extremely short TTLs through cache control headers on our objects. So where we would cache an image, we would put a cache control header of like a year on an image because it's static and it's not changing. We'll put a 10-minute cache control max age on a piece of HTML, on a dynamic piece of dynamic content. However, this isn't foolproof. Let me give you an example. Imagine that you're a news agency and you decide to put your static stuff on a CDN and you're like, I'm really brave, I'm gonna put a 10-minute timeout, 10-minute max age on my pages, on my base pages. You ship them out to your CDN and one day you ship out a news article and about a minute after you ship it out, you realize that you goofed and it's actually all hogwash. You have 9 minutes of terror as the thing times out of the CDN. This is an actual story. What I'm telling you is, I can't tell you which news organization, but it's an actual story. I'm going to tell you the second part of this story in a few slides. So that's one way we've been doing some dynamic caching, micro caching, if you will. Instead of long expiry, we've used extremely short expiry. We get it on the CDN, that's kind of cool. We've also used something called ESI in the past, if you've heard about it. ESI includes as a way of taking your HTML page, sort of fragmenting it into pieces, and having different cache heuristics on each of those pieces. And it's the CDN's job to assemble that page at the edge and ship it to the client. So you'll take partial caching essentially as a solution where you partially cache this HTML and the dynamic pieces of it you call back to origin. So there are still calls that go back to origin, but the bulk of the page is sort of cached at the edge. This is kind of onerous and painful, and it'll still require some trip back to origin. So that is ways that we've been sort of try to get around the no invalidation framework problem by doing some caching at the edge. And it turns out, as you probably already know, that dynamic content is a lot more cacheable than we think it is. As a matter of fact, it's probably cacheable for shorter periods of time. So maybe a piece of like an HTML won't be static for a year, but it's static for shorter periods of time. But the problem is, it is static for unpredictable times. So it may be static for now for half an hour, and then it may change 10 times in the next hour after that. It's very unpredictable, and it's that unpredictability that causes the problem. And the fact that we don't have the caching rules to deal with that is what causes this extra panic for us when it comes to caching dynamic content. However, we know that would be much more awesome if we did, right? If we were able to get that page on that CDN node on the West Coast and be happy about it and not have these fits of terror as our content becomes invalid, that would be a much better way of serving our clients. So if you had a waterfall chart that looked like this before you even use the CDN, then it goes and becomes like this when you add static CDN, a CDN for your static content. Notice that the little greens and the oranges got shorter. The greens are time to first byte. The oranges are TCP. I know this is just awesome animation right here. Great. But notice that that blocking thing is still there. And wouldn't it be awesome if that blocking thing moved to the left and your waterfall looked like this? So there's lots of benefits to this. We would have better performance, the page gets delivered faster, our users are happier, the page renders quicker, and we have the added benefit of having offload from origin when the origin that does most of its work on generating these dynamic pieces of content, even though they may be generating the same thing over and over again, we sort of give that origin a break. So that's awesome, great, that's a lot of lip service. These are things that we can't do. It seems like I'm just defining this panacea. How could we make this all better? Well, it would start with something that I'm going to call programmatic invalidation. I'm only calling that for about a minute because it's going to take another term in about 30 seconds. The idea here is to have an invalidation API, a way that you, as the content owner, can invalidate that content from the CDN. This has to be granular, means you have to be able to do this for specific URLs, for groups of URLs, for all the URLs, depending on how your site is designed or formatted or structured. This is what we call purging in the world of CDN. So this is what a purge is. And the idea is that as the page gets updated or published, you also issue a purge to the CDN to invalidate it from the CDN. So the CDN comes and fetches the new thing from you. However, all of this is meaningless unless that purge is instant. And that's the key here. That purge needs to happen instantly. It has to happen right away, and it's the instantaneousness of the purge that makes this actually work, that gives us the sort of tools to be able to cache dynamic content. This is a big problem with classic CDNs. There's tons of stories about multi-minute purges. I had somebody tell me that I asked them what their purge time was, and they said, we're lucky if we have 49-minute purge times, which sounds ridiculous. Let me finish the news story, story for you guys. So remember that it was a news organization that was publishing news, and it put 10-minute timeouts on its HTML because it was okay with the CDN caching that HTML for 10 minutes. One day they put out a news article, and within a minute, they realized that it was a boo-boo. They made a mistake, and now they had to get that news article off the ether because it was now cached in the CDN. Their CDN purge time was 12 minutes. So they had 9 minutes of absolute terror and anxiety while their object invalidated itself from the CDN because the purge time that the CDN provided was not good enough for them. It's that sort of stuff that creates this extra level of anxiety for us. What is instant? Well, it's certainly not 12 freaking minutes. That's not a thing. It's also not, and this is an actual question. I did this talk a week ago, and somebody asked, well, when I send a purge out, my CDN says, yes, I got your purge right away. Is that instant purging? No, it's not instant purging. That's just instant high-fiving. You have a whole amount of time between when you send that request and when the thing actually comes off the CDN. So it's not any of those things. What is it? I'm being generous by calling it sub-second. It needs to be even faster than that. It needs to be very quick. The only way this is going to work is if it's instantaneous, and it has to be predictable, and it has to be deterministic. Those things, you have to be sure that once you send the purge command to your CDN, the object comes off the CDN, it happens right away. That lets this whole machine work where you can cache some of your dynamic content. This also includes the propagation of that purge. So it's not enough for it to be purged from a single cache node. It has to be propagated through the entire CDN. If you did see Tyler and Bruce's talk yesterday about an invalidation framework and invalidation mechanism that does this, you'd have an idea of what that kind of looks like, certainly what it looks like for Fastly. That's not where purging stops. There's lots of other things you can do with purges. You can build purge dependencies. At Fastly, we have something called surrogate keys. Any other CDN should have a similar mechanism where you can tag objects and label them and then purge by label. And again, the key here is that it needs to be instantaneous. For all of this to work, it has to happen very quickly, right away, instantaneous, and then you can have essentially the power to cache some of these dynamic objects. Let me make an important point here. That is not to say, by doing this, we have not obviated this business. This stuff is still valid. There are still plenty of use cases where you need to accelerate objects from origin to the user, because there are things that are truly dynamic. They change on every view. They change, something about them changes with every iteration. Those things still exist. I'm not saying never do this anymore. But what I am saying is with Instant Purge, at least Instant Purge is part of it. We'll talk about the second problem of visibility in a bit. With these mechanisms in place, you can certainly cache a lot more than what you were capable of caching before, and hopefully do it without the anxiety that comes with just using caching headers to determine invalidation. If you have an invalidation framework that you can interact with your CDN through, that's certainly something that's going to help you cache some of these dynamic objects. Let me give you a couple of examples. Here's an example of a purge mechanism in place with a CMS. So I'm going to use WordPress as an example, not because I'm picking on WordPress, it's just a CMS. It's a thing, we all know it. Imagine that you have a WordPress blog and you're blogging. So you have a origin server that's WordPress, you have a blog entry that you create, you have a CDN that's fronting you, users come to the CDN, CDN comes to you, grabs the page, and this goes back and forth. You may edit your post at any time, whenever you feel like it, totally unpredictably. People can come and comment on that post whenever they feel like it, totally unpredictably. And because of this, because that happens totally unpredictably, you have decided to never cache the root HTML on your CDN, but you're okay with caching all the images that root HTML references. And you have waterfalls that look like this, and you're extremely sad because you realize that your very little page has half of its load time caught up in the HTML, in the root object. In this case, the very first one is actually a redirect. Even if we got rid of that, half of this HTML, half of this page load time would be caught up in that HTML. Wouldn't it be awesome if we could cache that thing on the CDN and not have to worry about this? So what does this look like after the fact? Well, here's your blog post again. You've published it. You serve it to the CDN when the user comes and fetches it. And let me highlight that. Can you guys see that? That orange? Now, totally long time is not actually a valid cache control header, just for the record. Never use it. Or if you do, let me know. We'll be happy together, and then we'll break things. So the idea is actually you can make the CDN cache it for as long as you feel like it, because you're about to do something cool in a second. So you cache it for a while, and this object gets pushed to the CDN, and users from that point on will fetch the object from the CDN, and that's great. Let's say some time goes by and people start commenting on your blog post, or you start editing it because you feel like it, because the comments told you that you're an idiot and you want to fix something, because that's usually how these things work. What you'll do is you'll issue a purge command to the CDN, and the CDN will say, okay, I don't need that object anymore. So this object goes away. What's the key? It has to be instantaneous. For this to work, that has to be an instantaneous delete from the CDN. And then the cycle repeats. The next request comes in, the CDN comes and fetches it from you again, and that object goes to the CDN, and everybody's happy. So what did we do in this example? We took something that was, it's a very good example, it's a simple example, but it's a very good example of a very unpredictable change or update model for a blog post, be it an edit or a commentary, or people commenting on the blog post. And that would normally lead us to no caching of that base HTML on the CDN. We took that, and with the idea of instant purge, we're able to cache that object on the CDN. Let me do a more complicated example, and I really, really love this example, but it takes a second to set up, so humor me and work with me for a second. Let's imagine that you are a third-party provider. You have a service like tag management. You have a service like A/B testing, analytics, performance RUM. You have some service like this that's deployed through a JavaScript. I am a customer. I'll be customer one. Hi, customer one. I'm customer one. Hi, hello, third party. And I'm coming to you and saying, look, I have a website, customer1.com, and I want you to do this cool stuff that you do on my website. So I want you to, I don't know, do tag management on my website, do A/B testing on my website, do analytics on my website. And you say, okay, that's cool. Here's a portal. Go and configure all the features that you want. And after you're done, here's a JavaScript that you get to put on your site on www.customer1.com. This is common, right? We do all this stuff all the time. The problem is when I go and edit that my configuration, there is that JavaScript may change, and things inside of that JavaScript may change. So you as a third party don't want to tell me that every time I make a config change, I have to change the JavaScript that I embed in my page. You want the thing that's in the page to always be customer1.js. So how do you handle this? Let's talk about before and after. Let's see what it looks like through our fantastic animation. I have a site, www.customer1.com. That's my website. I have put your tag, which is customer1.js, but is fetched from your service, which is thirdparty.com, on my webpage. As people come to my website, they render the page, they do whatever they do, and now when I want them to start using your service to do whatever measurement, add whatever thing that I'm doing, they'll come to the CDN, which will be your CDN, and they'll fetch customer1.js. For this to happen, this is again the before scenario, the request goes to origin, that piece of JavaScript gets fetched from origin, but what you do is you do this. So you put a max age header on that piece of content that's only a minute. So you're okay with that object, and this is an actual story. So again, I can't tell you who it is, but this is an actual thing. What I'm telling you actually happened. I don't know if that was clear, it's an actual thing. What you do is you put a 60-second max age on this, and you serve it to the CDN, and the CDN says, okay, that's cool, I'll cache this for a minute, if that's what you want me to do. You'll also serve that to the client, who also caches it for a minute. And then what happens after a minute, when not necessarily that browser, any browser comes in and looks for customer1.js, what does the CDN do? The CDN says, okay, I have a version of this object. Caching rules in chapter 13 of 2616 tell me that I can still cache it, but I can't serve it to you without validation. So what I'll do is I'll send a validation request to Origin that says, hey, Origin guy, thirdparty.com, did this thing change? And I use a validator like if modified since. So that request goes to Origin, and you say, you know what? Customer 1 hasn't been here for like weeks. So no, it hasn't changed. So you send me a 304, and I say, okay, I'm cool. I'm a CDN. I'll just serve that object to you. That's cool. Why has thirdparty.com done this? Because at any moment, me, a customer, or any of their other customers, thousands and thousands of customers, can go in and change the configuration that impacts the content of that JavaScript, right? Because that happens, they need to make it that the CDN only caches it for short periods of time. So what they've done is they've made their problem an invalidation problem. So where it would be really cool if this object stayed on the CDN for a long time, they've said it can stay on the CDN, but I kind of want to know about it every time or after every minute. I want to know about it. So I'll just validate it after a minute. Most of the requests to this object are going to be successful validations, and the CDN gets to cache it, serve the cached object, except the validation takes time. That is a round-trip latency that's incurred for every one of those validations. The validation is very small. There's no content that gets transferred, but that takes time. If you're going from the west coast of the US to the east coast of the US, that's about 70 milliseconds. If you're going from Washington, DC to Frankfurt, that's about 100 milliseconds. That takes time, and wouldn't it be awesome if we could just serve that from the CDN? So how do we do it with this cool new purging mechanism that we talked about? Same thing, the customer1.js gets requested from a browser that's on customer1.com's site. The request goes to to Origin. The Origin serves it with new cache control headers. We still have the max age equals 60, but we have a new cache control header called smaxage. Do we know what smaxage is? Show your hands. Awesome, I get to teach you something. Smaxage is in chapter 13 of 2616, and the S stands for shared. So it's a cache control, it's a max age cache control header specifically for shared caches. This includes a CDN, it also includes a forward proxy, but it includes any CDN that's cached. What it doesn't include is the browser cache, which is a private cache. So smaxage is a header for public sort of shared caches. That's the S part. And don't ask me why maxage has the hyphen between max and age, and smaxage has no hyphen between max and age. I have no idea. I'm a geek for noticing it, yes, but I have no idea why it's like that. So what have we done? We put max age at 60 seconds, so the browser's still only allowed to cache it for 60 seconds. We'll talk about that a little bit later. But I've told my CDN to cache it for a long time. That's the number of seconds there are in a month. So I tell my CDN to cache it for a month, and the CDN says, hey, that's awesome. I'm going to totally honor that. I'm going to cache it, serve a cached version of it to the client, and that's the way we're going to live from this point forward. Now, let's say a minute goes by, and a request comes in for customer1.js. Nothing is different. The CDN says, I was told to cache this for a month. I'm going to keep serving the version of it that I have in my cache. So this keeps happening over and over. I realize this animation is mind-boggling. If you could just hold your applause until the end, that would be awesome. This happens over and over again. Many, many times does this happen. There are many, many happy customers because we were able to get this thing that we were petrified of serving an invalid version of on the CDN and cached for a long time. Now what happens if customer one all of a sudden remembers that they have this cool service they're using and says, I got to go change the config on this thing because I want to add 2 features. I want to change my A/B testing. I want to add a new tag to the tag management system. I want to change the way analytics are measured, whatever. Something that's going to lead to the content of customer1.js changing. Okay, I do that edit over here. What happens? You as the owner of that object send the purge command to the CDN and say, hey, why don't you purge customer1.js? And me as the CDN says, that's awesome. Again, this piece needs to be instantaneous. And then the next request comes in for customer1.js. It gets sent to Origin. You send your cool new headers back to the CDN, and the cycle continues. So that's a way that we can totally change the the paradigm, if you will, of caching these pieces of objects, these content that traditionally we've considered dynamic. Notice the way, and again, these were both true stories. Notice the way that thirdparty.com was handling their unpredictable changes in content. They didn't know when customers were going to come in and change the content of that JavaScript. So what they would do is they put really, really short cache control headers on there and just lived with lots of validations. And even though lots of those validations, most of those validations were successful validations, they just kind of live with it. Let me take a quick detour. And you probably noticed that we didn't change the max age header on this transaction. The browser in this case is still only caching that object for 60 seconds. So if that same browser went back after a minute, it would need to do a validation to the CDN. There's two things here that are important to notice. First is that validation to the local CDN node doesn't take as big a hit as the validation all the way to origin. It's shorter, right? The CDN is going to be 3 milliseconds away from the browser. That's the first thing. The second thing is that's not actually the point of this discussion. There are far more interesting things that we can talk about for that browser better caching that particular object. It's just outside the scope of what we're talking about. There's a couple of tricks you can do. There's ways you can write self-updating scripts. We can talk about it afterwards if you guys like, but I've sort of left that out of this on purpose. Now, so let's do a quick review up until here. We talked about how we don't like caching dynamic content. We don't like doing it primarily because 2616 didn't give us a very good invalidation framework. We also said that we don't want to cache it because we would lose visibility if we did, because if the thing sat in the ether, we wouldn't see it hit our servers. We wouldn't be able to collect the stats and the logs that we really, really like. Instant purging would really help us address the first issue. We looked at a couple of examples. Our mind was blown by the animation. It's awesome, and that's what instant purge gives us. But as we discussed earlier, it's not just about invalidation. There's more things that have caused us in the past not to cache dynamic content. And to talk about these things, I kind of want to step back for a second and pontificate for a second, if you will. Please humor me. I want to frame the idea of visibility into a bigger discussion. And I'm only going to touch on it for a little bit, but hopefully this will give you some food for thought. So what I've noticed, I've been with Fastly now for 5 months. That is the first company I've been with in a CDN world. I've worked with CDNs in the past many times, but I've had very little contact with actual CDN users. What I've noticed since being inside of a CDN is the way we seem to be using our CDN seems to be changing. And the way I think about it, maybe this is a naive way to think about it, it seems to be very influenced by the clouds, by all the clouds that we've been using, all the AASs that we've been using as we build our apps. The way we've been interacting with these services is changing the way we interact with our CDN and the expectations that we have on our CDN. Where in the past, the CDN was essentially a black box, this thing that you just sort of trusted did all the cool stuff that they told you they would do. We sort of see the CDN as an extension of our app anymore. And if we don't, we would like it if that was the case. We would like it if we could just extend our application to the edge nodes that the CDN provides for us. This black box model isn't really working anymore. This means real-time integration. This means real integration with the CDN. That's something that I think the way we've been interacting with the clouds has influenced the way we think about CDNs. If you think about it, CDNs could arguably be one of the first cloud services that we ever had. There's no reason you can't have the same expectations from your CDN that you have from any of the other services that you build your apps around. We talk about infrastructure as code. There's no reason that the CDN can't also be part of your code. At the risk of sounding extremely cliche, there's no reason that the CDN can't be content as a service for your applications. Yes, I dislike myself for saying that, but it sort of frames the conversation. What does this mean? This means, first and foremost, control. And control comes in the form of programmability. You, as a person who's writing applications and designing and architecting applications, should have full programmable control of your CDN. What does that mean? It means a configuration API. It means an invalidation API, like we talked about. And all these things have to be instant and real time. In case that's not clear, instantaneousness is a key component of all of this, because the same way that you expect your services, any other services that you use to give you instantaneous feedback and do things for you instantaneously, you should have that same expectation of your CDNs. So programmability means full API, means an invalidation API, means other APIs that I'll talk about in a second. It also means full control over what you can cache. So that means dynamic caching. That means having extremely flexible caching keys. You should be able to key your cache objects any way that you want. Let me give you an example. And again, this is also a real example. You're a travel site, and you've decided that you want to serve a different piece of content to people based on their geographic location. That seems extremely fair. You want somebody that's standing at Grand Central Station to get a different piece of object, a different page or a different set of search results for travel stuff than somebody who's standing at JFK, because there are different hotels that are near them, or there are different bed and breakfast places that are near them. So if you want that, you should be able to cache, to key your objects by geo-IP information. Whereas normally a cache key is hostname and URL, full URL, you could say that, hey, I want it to be hostname, URL, and some sort of normalized geo-IP information. That's an extremely fair thing to expect from your CDN and when you're caching stuff. That's what I mean by caching control. So it has to be granular, it has to give you full control, and it has to let you do things the way you want to do them, because again, the CDN is supposed to be an extension of your app. You should have the same control over the CDN that you have over your own infrastructure. This also means controlling things at the edge. It means moving some of the application logic to the edge. Now, how many of you are familiar with Varnish? Is Varnish a thing? Great. So in Fastly, we use Varnish. This is one example. VCL is a very good example of this. If you've ever seen VCL, the Varnish config language, it sort of reads like a script. So it has a lot of logic that's built in. That's not to say this is the only way that you can move some of this application logic to the edge. Any CDN should be able to give you these tools to be able to do some of this programmatic integration at the edge, so you can be able to move some of your logic to the edge. There's no reason that you can't expect the edge to do some of the work that some of the heavy lifting that you're doing at origin. You should be able to do that stuff at the edge. So it's control. That was a big thing, and caching control is a big part of it. Control over what you cache and how you cache it. Visibility is another one. And remember earlier we talked about how one of the big reasons, the second reason that we were afraid of caching dynamic content, other than the fact that we don't like serving stale content, there's no invalidation framework, is that we lose visibility. So how is a CDN supposed to solve this problem? Well, the CDN better give you real-time analysis and real-time logs. You should get network stats. You should get HTTP stats. You should get caching stats. There should be a caching, a stats API. Same way that there's an invalidation API and a configuration API, and there are instantaneous, there better be a statistics API so you can get that information from your CDN. Again, it needs to be an extension of your app. Your tentacles should be extended to the CDN. It should not any longer be a black box. Those things need to be there for you. So does logging. Logging needs to be there. You should be able to get real-time logs from your CDN. They should be streamed to the services that you like to have them streamed to. These are things that you should be expecting from your CDN in order for you to be able to push some of this stuff out to the CDN and integrate your app with the CDN. Let me do a couple of examples of this. Beacon termination. We all familiar with what beacons are? Right? Like Google Analytics or some analytics service or RUM or something like this, where you collect some information of the browser and then you call back home through a URL that's got a bunch of query parameters that sort of collect that data and report back to some analytics engine. This is kind of what it looks like. You have the browser collecting a bunch of stuff, sending a request in the form of a normal image, little tiny image, with a whole bunch of query parameters that have the collected data in them. In this case, we've collected piece of data A, piece of data B, piece of data C. We shoot it to the CDN. CDN ships it home. All that origin server is doing is collecting these things and basically writing logs. It responds to this with a tiny little image. This image is actually totally immaterial to the design of the page. It means nothing. It's a tiny image. It disappears. You never see it. It's a response because every request needs to have a response. So it's a response that goes back, goes all the way to the user. We don't care about it. And then some sort of log analysis engine takes these logs from that origin server and starts doing stuff with them and doing data analysis, and you get cool big data warehouses. You do lots of cool things and have data scientists on your payroll. That's how it was before. How do we do this with this, cool idea of pushing some of this stuff to the CDN? Well, that beacon can still come from the user and hit the CDN node, but what if we cache that particular little tiny object image, which is totally immaterial to the rendering of the page, on the CDN, and we just shipped it back to the client as is? Better yet, what if we told the CDN to just send a 204 back to the client? 204, in case you don't know, is one of the status codes defined in 2616. It means there's no content in the object. Basically says, I got nothing to give you. It's just a response, so there's a response. There's nothing in it. And actually with beacons, lots of beacons do this. I think GA actually do this, Google Analytics. It actually doesn't matter what the response to that object is. All it is, all we care about is collecting the query parameters that are in that beacon. Now, what if that CDN node then streamed all those things, all those requests, to some sort of log analysis or log termination point, S3 bucket, syslog, FTP, whatever you wanted that termination point to be. What if that CDN node did that for you? That would be kind of cool. Notice something really interesting in the afters. 1, 2, 3, 4. Notice there's no arrow from the CDN to the origin. This is an originless application on a CDN. It's pure 100% terminated application on the CDN, and we've just built a beaconing mechanism only with the CDN and nothing at origin. That's kind of cool, right? That's the sort of things that you should be expecting from your CDN, where the traditional model is you have an origin, you better go fetch some stuff from the origin. Here's one thing, I understand it's simple, but it's actually very doable. To be honest with you, hopefully next year I'll tell you about the thing that we just did that does this exactly. This is a very, very normal expectation that you should have from your CDN, and this is an example of how you've extended your application to the edge. And in this case, log streaming and streaming logs to your whatever endpoint you like has sort of helped you deploy this application. What about if we generate some content at the edge? Let's do another example. We have some partners and ourselves actually that like to know which CDN POP they fetch content from. So what they do is they write this little piece of JavaScript. In this case, it's whichdatacenter.js, that's an example. And they fetch it from the CDN. And the CDN knows that if it ever sees this particular object, it actually just synthetically responds with a little JSON object that says this is the data center you ended up in. That's actually a real example. And again, it's something that I put the origin server on the thing to be on there, but it gets not used at all. This is an example of edge-generated content. We generated this content at the edge. We don't use the origin at all, yet we've delivered to the browser the POP that we ended up in. This is again, I use VCL as an example, but any, say, CDN with any notion of this should be able to give you this. That is extremely dark. If you were to totally be able to read it, you'd see some code that actually generates that. I'll post these slides afterwards. That's not where it ends. What about if we did stuff with GeoIP? You can do the same thing with GeoIP. What if your request was for geoip.js and you got a piece of JSON back that had your city, your state, your country, the IP address that you had? You know these like whatsmyipaddress.com services? They could do the entire thing by caching the HTML on the CDN node and having a little JSON call that goes to the CDN and fetches all that piece of information from the CDN. There's no reason that you can't be able to do this stuff with your CDN. It's a great example of how edge-generated content sort of lets us push some of that application logic to the edge and use the CDN as part of our application. It's not a black box anymore, and this is a cool thing. This is something we should be able to leverage. Here's some blog posts. Again, so I'll post the slides online so you guys can see this stuff. Some more interesting write-ups on things like caching cookies, API caching, log streaming, some further reading if you're interested in this stuff. Let me sum up. We've talked about the fact that dynamic content can be cached a lot more than we think it can be cached. It can be cached if we have instant purging. It was very important for us to have instant purging. It's this instantaneousness of that purge that lets us cache without the anxiety that would otherwise come from just using cache headers. We need real-time logs and stats to be able to do some of this caching, so that visibility that we were used to before doesn't go away. We really like it would be really cool if we could integrate our applications with the CDN and do real-time integration with the CDN. This means we need to have extensive APIs, be they for stats, for configuration, for invalidation, things that give us control over the CDN infrastructure. And that control and visibility lets us be very, very creative. I just showed you some very simple examples, but I'm sure you're already thinking about cool things that you can be doing once you have this ability with your CDN. Obviously, never ever use totally long time as a cache control header because you'll break stuff. I will love you for it, but you'll probably break your applications. I went very, very quickly. That's the end of it. That took 45 minutes. I hope that was helpful. We have time for questions. And if we don't want any questions, I think you can go eat. Are there any questions? Yes?
Thanks, great talk.
1 second. He said it was a great talk. Go ahead.
I think the answer is no, but are any of the CDNs thinking about establishing common APIs? Because basically the thing that would hold me back from doing too much stuff at the edge is it would create more lock-in.
Yeah, you get locked in, which was an ESI problem as well. This was a problem with ESI as well, was the lock-in, right?
So are you guys at all thinking about common APIs or not really?
The question, in case you guys didn't hear it, and it's a great one, is it's not great just because you thought the talk was good. It's actually a really good question. Is there a common API for doing this purging? As far as I know, the answer is no. I think you're right on that part. I think the protocols, like what I showed you earlier, was an attempt to do something like this. Two things to keep in mind as you think about this, and that's actually a good thing to push. I mean, we're certainly not opposed to it as a CDN provider. It's one thing to have the framework to do it, to say, hey, purge requests need to look like this. That's one thing to do it. Imagine that we have a new method, an HTTP method that was a purge method. That would be pretty easy to do. That's one thing to do that. It's another thing to make it instant. That's the piece that actually enables us to do all these things. So I can certainly support, and I could definitely see it happening, a common framework for the invalidation, but I would love if all CDNs had instantaneous purging. I just don't think everybody's there yet. Does that answer your question?
Yep.
Great. Yes? My answer, so the question is, has anybody done a benchmark to see what the purge times across all CDNs are? My answer is not only biased, but it's also anecdotal. So I have some numbers, but I don't necessarily want to make anybody look bad. I think that's a great thing if you're evaluating CDNs to do. You should do it. It should be part of the normal evaluation criteria if invalidation instant purge is a requirement, which I would hope after this would kind of be, you kind of see the things that you can do with it. So I don't have anything that I kind of want to tell you here, but we're going to be right over there. Come talk to us. I'm happy to tell you all the stuff that we know anecdotally and from what our own testing. I will tell you that 12 is a real number and 49 wasn't a real number, but I won't tell you which CDNs. Those are real numbers. Anybody else? Was it helpful? Great. Thanks for coming.